Here's our tea.
Thanks.
Let me put some sugar in for you. Okay, here's your lemon tea.
Hey, what has happened to my lemon tea?
Oh, what are these white particles here? Is there something wrong?
Let me see. You've put sugar in your milk and in my lemon tea. So, can it be the sugar?
But there's nothing wrong with my milk.
Maybe it's caused by mixing sugar with the lemon tea.
Let me get another lemon tea to try it out. Here it is. Let me put sugar into the empty glass first. Then, pour the lemon tea into the same glass. And stir it well. No change at all. There's nothing wrong with the sugar.
Well, just now you seem to have stirred your milk with a spoon before using it to stir my lemon tea. Maybe your milk is bad.
It's perfectly normal and it tastes good.
Can it be the mixing of milk with lemon tea that produces such effect? Let me try. It's true, the milk has coagulated.
So this is the result: lemon tea and milk mix.
What actually causes the change? The lemon, the tea, or the milk? Or do we have to mix all of them?
I've got an idea. Now, this is water with lemon, and this is tea only. Let me pour milk into 2 glasses and see what happens.
Nothing happens to the tea. But the milk in the lemon water coagulates.
So, it's the mixing of lemon with milk causes the coagulation.
Lemons are acidic. Will the same thing happen when milk is mixed with other acidic liquids?
Let me test it out. Here is a fresh grapefruit juice, fresh orange juice, and here's a vinegar. Let me test them one by one. All these acidic liquids produce the same effect when they are mixed with milk.
Which means when milk is mixed with acidic liquid, it will coagulate.
Do you think that the same effect will be produced if we tried it out with the acids in the laboratory?
Let's go to find Mr. Lee and ask him to help us with the answer.
gases, they make the milk coagulate.
Can we now say that all acidic liquids make milk coagulate?
The two students in the last clip have scientific minds. They made use of the scientific method to find out the truth of the matter. The first step of the scientific method is observation. From daily experience, they found out that there was something unusual about milk, which coagulated when it was mixed with lemon tea. The students repeated the test by pouring milk into grapefruit juice, orange juice and vinegar, and found that the milk coagulated in all of them. This is the stage of information gathering. From the information gathered, the students formed a hypothesis that milk coagulates whenever it is mixed with acidic liquids. Then they performed experiments with other acidic liquids to prove their assumption. Finally, they analyzed the results of their experiments and drew conclusions. Generally speaking, the scientific method proceeds in 6 steps. 1. Observation. 2. Information gathering. 3. Forming a hypothesis. 4. Performing experiments. 5. Analysis of data. And 6. Drawing conclusions. The scientific method is a human activity. By making use of it, we understand our surroundings and find out the laws of nature and many other things. Our knowledge is the outcome of careful investigations. Aristotle, the great philosopher of ancient Greece, observed leaves and stones falling onto the ground. He made the following conclusion. The speed of objects falling is in direct proportion to the weight of the objects. Heavy objects drop faster. Lighter objects drop slower. Aristotle's theory had been accepted for over 2,000 years, until it was queried by an Italian scientist called Galileo in the 17th century. A leaf tends to float in the air when it drops. Therefore, a leaf should hit the ground much slower than a stone. Now let me use 2 metal balls of identical size but different weights to illustrate my point. I'll drop the balls on top of the Tower of Pisa. Please help me to find out which ball hits the ground first.
They touch ground at the same moment.
Besides correcting the wrong prediction of Aristotle's theory, Galileo's major contribution to science was the introduction of experimentation into the process of the scientific method. In the last century, advancements in technology have greatly improved our living. All these are outcomes of applications of the scientific method. For example, when doctors try to diagnose the illness of their patients, they make use of the scientific method. Look carefully at the following case and see if you can mark out the steps of the scientific method. Please take a seat, Mr. Kwok. How are you feeling?
Doctor, I feel very tired and weak. Is it influenza?
Do you feel itchy?
Yes, and I cannot refrain from scratching. I feel thirsty. I often have to drink a lot of water and go to the toilet frequently.
And how's your appetite?
I eat a lot, but I'm losing weight.
Any problem with your eyesight?
It's a bit blurred.
All you told me just now are symptoms of diabetes. Have you eaten anything since last supper?
No.
Now I need your urine sample to look into the case more closely. The urine test shows that you might have diabetes. In order to confirm the case, I suggest you go to the laboratory for a blood test. Come back tomorrow to discuss the result. According to the result of your blood test, it's certain that you have diabetes. The Consumer Council's mission is to protect consumer rights relating to the purchase of goods and services. The Council frequently carries out tests on products. These tests are applications of the scientific method. The first step is to identify the problem. It all begins when a complaint is received. Then, staff of the Consumer Council proceed with observation and information gathering from various sources worldwide. Once the problem's been identified, a meeting of the testing committee is called to decide on the kind and amount of samples to be tested and to set out the scope and objectives of the test. After trial tests and revisions, staff of the Council acquire samples of the products under investigation from the market. The samples are passed to authorized laboratories for full-scale testing. In the case of toy testing, various kinds of tests are conducted to see if the samples contain toxic metals, if they are flammable, if they contain sharp corners and edges which are within the reach of children. It's also necessary to check the tension of the joints to see if they're easily breakable. And to check if they contain small parts which can be swallowed by toddlers. After the tests, the report is passed to the testing committee for further analysis. If the test results are considered accurate and reliable, they're passed to the publications department for editing. Finally, the test results are disclosed to the public. The scientific method has been widely applied in planning for the metropolitan development of Hong Kong. Hong Kong is a densely populated city with very limited land resources. A quarter of its land comes from reclamation. Reclamation, deepening of the seabed, construction of piers and dams and so on will cause damage to the natural environment by changing the current flow in the harbour. If the current flow becomes too rapid, the safety of ships will be hampered. If the current flow becomes too slow, sediments will accumulate at the seabed. The harbour will be silted up and the water polluted. To ensure that the design of the port development scheme would lead to a harbour with good water quality and smooth current flow, this harbour hydraulics laboratory was set up by the Government Civil Engineering Department a few years before the start of the scheme. Inside the laboratory, there's a model of the Victoria Harbour, constructed in the horizontal scale of 1 to 500 and the vertical scale of 1 to 70. The engineers are filling the areas shown in the model with reference to the Western Kowloon Reclamation Project of the Port Development Scheme. A computer-controlled device is then used to simulate the high and low tides of the harbour in order to investigate the effects of reclamation on the current flow. Photos of these foam balls on the water surface are taken once every 60 seconds. The foam balls drift about, resulting in these white lines in the photo. These lines indicate the pattern of current flow in the harbour. This is a flow meter to measure the speed of current flow. And this water level recorder is used to record the changes in sea level. The data are analysed to see if they're up to prescribed standards. The application of the scientific method can help verify the feasibility of the project and make necessary amendments of the design before the project is actually implemented. The scientific method is also applied in the Forensic Science Division of the Government Laboratory. In order to track down people who've committed criminal offences, scientists in the laboratory use advanced scientific apparatus to support the scientific method in forensic examinations. Look at this photo of a housefly taken by the electron microscope. The electron microscope can be used to analyse traces such as gunshot residues. This is an apparatus used to recover the contents of documents which have been erased or modified. And this is an apparatus used to check whether a piece of jewellery is genuine or fake. Research work employing the scientific method and supported by advanced scientific apparatus can help us to find out the facts in the real world and improve our quality of life. Let's review the steps of the scientific method. Observation. Information gathering. Forming a hypothesis. Performing experiments. Analysis of data. Drawing conclusions.